All right, here is your second triangle sort of recap video, and this one will be about right triangle trig, so often known as SOHCAHTOA. So our big idea here is talking about right triangles and the trigonomic functions that are the ratios between their angles and their side lengths. So this should be a review for you, but this should just be a nice recap. So sine of this angle theta right over here is going to be the ratio of the opposite side length over the hypotenuse. So for these trig functions here, when we're talking about right triangle trig, we always will input an angle measure, and our output will be a ratio of the sides. So that's something really important to keep in mind as we're moving forward here, is that I input angle measures into these trig functions and I output a ratio of the side lengths. So for cosine of theta, my ratio is of the adjacent side, so the side that's right next to theta, over the hypotenuse. And tangent will be the opposite side over the adjacent side. So here is my angle theta. The opposite side is what's exactly across from the angle, or also the side length that doesn't touch the angle at all. The adjacent side is the side that's right next to the angle that is not the hypotenuse, and the hypotenuse is always the side that's directly across from my 90-degree angle. So for example, here, let's go ahead and if I were to then go ahead and talk about this angle as the measure of angle M over here, this would then be the opposite side. Let's scroll up a little bit here. This would turn into my adjacent side, and my hypotenuse would stay the same. So it's important as we're going through and working with these trig functions that we're paying attention to what angle we're talking about, and we're paying attention to the side length in relation to that specific angle. So let's set up these problems using the following trig ratios. I don't know any of these angle measures, so I'm just going to fill in here. So here is A. Let's go back to my pen. Here is A. So for angle A, this side is my opposite side. This side is my adjacent side. And the side that's directly across from the right angle is my hypotenuse. So let's just go back when we talk about sine of theta. I have the opposite over the hypotenuse. Cosine of theta, I have the adjacent over the hypotenuse. That should be an equal sign there. And tangent of theta, I have the opposite over the adjacent. So sine of angle A here will be 8, which is the opposite, over my hypotenuse, which I don't quite know yet. So let's take a look at this ratio here. Let's take a look at this triangle. I can use my Pythagorean theorem. So 15 squared plus 8 squared is going to give me that h value there. So I can come in, and 15 squared plus 8 squared is going to give me, I forgot my squared there. 289 is equal to h squared. And when I take the square root of 289, I will end up with 17. So 8 over 17 is the ratio of the side lengths when I take sine of that angle A right there. So cosine is the adjacent, so 15 over 17, and tangent is the opposite, which is 8 over the adjacent, which is 15 here. So let's go ahead. We can erase this and sort of start over because now we're talking about angle B. So now this becomes my opposite side, this becomes my adjacent side, and 17 remains as my hypotenuse. So here. So sine of B is 15 over 17. Cosine of angle B is 8 over 17, and tangent of angle B will end up giving me 15 over 8, so the opposite over the adjacent. So there's just sort of using and setting up some of these trig ratios that we previously talked about. We can also use these trig ratios to find missing side lengths and to find missing angles. So let's start with finding missing side lengths. So the first thing that I want to do is this is what I'm trying to find. This is the angle that I'm given, although that's the angle that I'm given, knowing that this is 90 degrees and this is 70 degrees, could I easily figure out my third angle? I could, because I know that all of the angles add up to 180 in a triangle. And this is another piece of information that I'm giving here, that this hypotenuse is a measure of 7. So if this is the angle that I'm talking about, it looks like I'm looking for the opposite side. So I have angle, I'm looking for the opposite side, and I have information about the hypotenuse. So which one of my trig functions helps me with hypotenuse and the opposite side? That would be sine. So sine of 70 degrees is equal to x over 7. And what I can do is I can just solve for x here. So multiply both sides by 7. So I end up getting 7 times sine of 70 degrees is going to give me that x is equal to 6.58. And we'll round to 2 places after the decimal there, to the hundredths place. So that's the measure of angle x, of side length x over there. Let's take a look at one more over here. I have this angle right here, and let's take a look at number 4, this last one. I have this angle right here. I'm given information about the hypotenuse, and I'm looking for the adjacent side. So I know that I can use cosine of 55 degrees is equal to x over 20. So I can go ahead and multiply both sides by 20 to solve for x. So 20 times the cosine of 55 degrees gives me that x is equal to 11.47. So here is the measure of that side length right there. So we can use trig ratios to find missing side lengths by solving for that missing variable. Whoops, let's come back and flip. Okay, so the other thing that we can do is solve some word problems when we're talking about trig functions here. Whenever we're using our SOHCAHTOA or our right triangle trig, it's often for problems that have to deal with angle of elevation and angle of depression. Angle of elevation is usually pretty straightforward. It's the angle you lift your eyes through to look at something that's above you. So looking here, here's my horizontal. It's the angle made from the horizontal going up. This is my angle of elevation. Angle of depression is sometimes a little bit trickier. So I always think for angle of elevation and angle of depression, we're starting with the horizontal and we're either shifting our eyes up for the angle of elevation or down for the angle of depression. So here's my horizontal, here is my sight down, this is my angle of depression. So let's go ahead and take a look at a quick example for this. So it says the angle of depression from the top of a cliff to a ship at sea is 14 degrees. The ship is 500 meters from the shore. Find the height of the cliff. So here is my cliff, and it looks like I'm talking about the angle of depression from a top of a cliff to a ship at sea. So here is sort of my sight from the cliff to the ship at sea. But what I need to remember is that I need to draw in a horizontal here. So the angle from the horizontal going down, that is my angle of depression. And I know that so many kids always want to use this as their 14 degrees. But if you always remember that it's the angle from the horizontal going down, it will make things a little bit easier for you. So we can go ahead and use some right triangle trig to solve this problem. So I know that we'll call this a right angle right here. If this is 14 degrees, I know that the other part of this angle here, if I were to add these two pieces together, that this would also make a 90-degree angle. So I'm going to call this 76 degrees. And knowing what I know about triangles is that this becomes 14 degrees down here. So I have information about either of these angles. So let's go ahead and say that this is the angle of interest, and I have information about the opposite, and I'm looking for information about the adjacent. So I can go ahead and say that tan of 76 degrees is equal to 500 over x. And I can multiply both sides by x and divide by tan of 76 on both sides. And so I end up isolating x to see that x is equal to 124.66, and we'll call it meters. So that would be the height of my cliff here. So we can see how if I said that this was 14 degrees, which it's not, but sometimes that can be labeled incorrectly, that we wouldn't end up getting an appropriate answer here. So moving right along, and I know we're kind of going through these a little quickly. Again, this should be a review. So moving right along with this right triangle trig, let's go back. Sine of A here is going to be 4 over C. We can quickly figure out C by saying that 3 squared plus 4 squared is equal to C squared. 9 plus 16 is equal to C squared. So C is 5, or I also could have recognized that this is a nice 3, 4, 5 triangle. So sine of A, opposite over hypotenuse, so 4/5. Cosine of B, adjacent over hypotenuse, so again 4/5. And tangent of A is going to be opposite, so 4 over adjacent, which is 3. So you'll notice I don't know any of these angle measures except, of course, for my 90-degree angle. We wouldn't be able to use right triangle trigonometry if we didn't have a right triangle to begin with. So I know that that's 90 degrees, but I don't know anything about the measure of angle A or the measure of angle B. So let's take a look here. This is saying find the measure of angle X. And you'll remember from the beginning of this video that we talked about sine of theta is the opposite over the hypotenuse, and I input angle measures into these trig functions, and it outputs a ratio of their side lengths. So let's go ahead and set this up with everything that we know. I know that I'm talking about the measure of angle X here. And in relation to the angle X, I have information about the opposite and the adjacent. So let's say that tan of angle X is equal to 7 over 5. So you'll notice here I have the ratio of my side lengths. I'm not searching for a side length. I'm searching for an angle measure. So what I can do is I want to go backwards. Instead of trying to figure out what this trig function is equal to as a ratio of side lengths, I'm looking for an angle. So I want to go backwards. And when we go backwards in math, we use the word that's called inverse. And I know we talked about this at the beginning of the year as well. So inverse functions. So I can say that tan inverse, so inverse is going backwards, so instead of plugging in a ratio of side lengths, instead of plugging in an angle measure into my trig functions, I want to go backwards and plug in the ratio of the side lengths so that it then outputs an angle for me. So I can come over to the inverse button on my calculator. Tan inverse of 7 divided by 5 is going to give me 54.46 degrees is theta, or that's what my angle X is equal to. So X, that's what angle X is equal to here. So let's go ahead and do another example of one of those. So again, I have my regular trig functions, and I'll use cosine as an example this time. So I have adjacent over hypotenuse. If I want to go backwards, if I'm looking for an angle measure, I can go backwards and use the inverse. So cosine inverse, instead of plugging in an angle, I'm using the inverse, so I'll plug in the ratio of my side lengths, and that will output an angle for me. So looking at the measure of angle A here, I have information about the adjacent and the hypotenuse. So I will go ahead and use cosine. So cosine of angle A is equal to 6 over 10. Again, I'm looking for that angle measure, so I want to use the inverse. So cosine inverse of 6 over 10 will output an angle measure for me. So cosine inverse of 6 divided by 10 is going to give me that angle A is equal to 53.13 degrees. So there is a few examples for you. There are a few more that are sort of in this packet for you that's attached. You're welcome to go ahead and work through those. Other than that, there are some finding missing side lengths, finding missing angles, and some angles of elevation and angles of depression practice problems for you to work through for this section's homework.